Hello and welcome to my science tutorials. In today's video, we want to look at parallel and perpendicular lines in coordinate geometry. So without further ado, let's begin. So we want to first of all look at the first diagram that we have here, which we are describing as parallel lines. So if we have two straight lines that are adjacent to each other and are either moving in the same direction or in the opposite direction, but they will never meet at any point, then we say these two lines are parallel to each other. Now these two lines, assuming you take a point here, let's say point A, and then another point here, point B, and then you take another point on the second line over here, let's say C, and another point here, D. If you calculate the gradient for the first line, the gradient will be equal to that of the second line. So we say for parallel lines, the gradient M1 for line 1 will be equal to the gradient M2 for line 2 because they are parallel. Now for perpendicular lines, we have these two lines crossing each other, making an angle of 90 degrees. So as you can see over here, we have an angle of 90 degrees over here. So if we have two lines crossing each other at an angle of 90 degrees, then we can describe those two lines as perpendicular lines. Now if we calculate the gradient M1 for line 1 and calculate the gradient M2 for line 2, we realize that if we multiply these two gradients, we'll get -1 for perpendicular lines. So it means for parallel lines, their gradients are equal, whilst for perpendicular lines, if you multiply their two gradients, you get a -1. Now let's go ahead and look at some problems on how parallel and perpendicular lines can be applicable in solving problems. So we have A and B are points 2,5 and 6,3 respectively. We have to find the gradient AB, the gradient of line perpendicular to AB. Alright, so let's go ahead and look at the solution for this problem. So we have solution here. We have point A, which has the coordinates 2 and 5. And then we have point B with the coordinates 6 and 3. Now, for me not to be confused, I will label my coordinates. So this is my x1, my y1. This is my x2, my y2. So that when I'm solving, it is easier for me to easily pick my coordinates. Now, the first part of the question is demanding that I find a gradient AB. So the gradient of the line AB. So the gradient M of the line AB is given as the change in the y-axis. So that is y2 minus y1 on x2 minus x1. So this is equal to my y2 over here is 3 minus my y1 is 5 on my x2 is 6 minus my x1, which is 2. So I have from here -2 at the top on 4, and this will give me my gradient to be equal to -1 on 2. So my gradient M for the line AB is equal to -1 on 2. Alright, so the II aspect is saying the gradient of a line perpendicular to AB. Now, assuming this is the line AB, and then we have another line perpendicular to it, it means that line will cross the line AB, making an angle of 90 degrees. And like we saw in the previous example, or in the previous explanation that I gave, we said that if we have the gradient of 1, if we multiply it by the second one, because they are perpendicular, they should give us -1 as their product. So I'm going to say this is M1, so that is the gradient of line AB. So my M1 multiplied by M2 should give me -1. So if I make M2 the subject and I substitute the value of M1, which is the gradient of line AB, I should be able to get the gradient of the line perpendicular to AB. So let's go ahead and look at that. So my M2 here will become -1 on M1. So my M2 is equal to -1 on 2. This is equal to -1, which is the top here. To change the division sign to multiplication, I reciprocate what I have here, so it becomes 2 on 1, negative 2 on 1. So 1 multiplied by negative 2 on 1, which is equal to negative 2. So m over here will be equal to negative 1 multiplied by negative 2, and that will give me a positive 2. So the gradient of the line, let's say this line m2, 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 the gradient of the line m2 over here is equal to 2. Alright, let's have a look at another example. We are to show that the lines joining P, points P 27, Q 32, and R 05 form a right angle triangle. Alright, so this is the diagram showing the point P, R, and Q, and then our others. So let's look at the solution for this problem. Now, if we look at the diagram that we have very well, the question is demanding that we show that the lines joining P, Q, and R form a right angle triangle. Now, if you look at that, the only two lines that can give us a right angle triangle is the line PR and then RQ. That is, the angle over here should be 90. If the angle over here is 90, it means line PR, which is P and R over here, and line RQ are perpendicular. And because they are perpendicular, we are expecting their gradient to give us a negative 1 when we multiply them together. So let's go ahead and calculate their gradient and see that. So the gradient of PR, line PR, will be equal to y2 minus y1 on x2 minus x1. As usual, I'm going to write my points 2, 7, my q 3, 2. So I have PR. So this is P. Let me write R over here. So R is 05. So this is for the first line P and R. So P and R over here. The second one is R and Q. So let me erase this. So for R and Q, their point R. For R, I have 05, and then for my Q, I have 3, 2. Alright, so I can now go ahead and label my points. So I have this is my y1. This is my x2, y2. That means from P to Q, P is the first point, Q is the second point. So these are my coordinates. So from R to Q, R is my first point, so this is x1, y1, this is x2, y2. Okay, so for my line PR, my y2, this is y2, my y2 is 5, so I have 5, minus my y1 is 7, on my x2 is 0, minus my x1, which is 2. So this is equal to 5 minus 7 will give me negative 2, on the denominator over here also give me negative 2, and this is equal to 1. Alright, so the gradient of the second line, which is R and Q, will also be equal to y2 minus y1 over x2 minus x1, and this is equal to my y2 here is 2 minus my y1 at the top, which is 5, over my x2 is 3 minus my x1, which is 0. So I have over here, from the top, I have 2 minus 5 will give me negative 3, denominator will give me 3, and this is equal to negative 1. Now we said that if it is true that the lines joining PQ and R form a right angle triangle, then we are expecting the line PR and RQ to be perpendicular, which means if you multiply their two gradients, that should give us negative 1. So the gradient of PR multiplied by the gradient of RQ. The gradient of PR is 1 multiplied by the gradient of RQ is -1, and this is equal to -1. So because we have -1, it shows that the line PR and the line RQ are perpendicular to each other, and therefore all these 3 points join together to form a right angled triangle. So thank you so much for watching, and I will see you in the next video. Bye bye.